Hello everyone and welcome to day 18 of our low-level design course. Today we are diving into two powerful behavioral design patterns that are heavily used in real-world systems, the command pattern and the mediator pattern. Understanding these patterns will not only improve the flexibility of our systems, but also make our code much cleaner, modular, and easier to extend. Let's get started. By the end of today's session, you should be very comfortable with both the command and mediator patterns. We will first understand what problems they solve. Then we will look at how they are structured, explore their key components, and walk through relatable real-world examples. Finally, we will practice designing using these patterns so you can apply them confidently in your own projects. Quick refresher before we go deeper. Behavioral patterns are all about how objects communicate and collaborate to perform tasks. They define not just what objects do, but how they interact with each other. Think of it like the rules of communication inside a big team. Good interaction makes teamwork smoother, bad interaction creates chaos. Command and mediator patterns are two ways to manage these communication rules smartly. Let's start with the command pattern. Imagine you want to issue a request like turning on a light, but you don't want the object sending the request to know the internal workings of the light. In the command pattern, we treat requests as objects. This gives us tremendous flexibility. We can delay a request, queue it, undo it, and even compose complex operations, all without changing the original code. The command pattern has a few important building blocks. First, there's the command interface, which defines an abstract method like execute. Then we have concrete command classes, where we implement specific actions like turn light on or turn light off. The receiver is the actual object that performs the action, like the light or fan. The invoker triggers the commands when needed without knowing the exact details. And finally, the client wires everything together. It knows which command to associate with which receiver. The advantages of the command pattern are huge. First, it decouples the sender from the receiver, meaning we can change either independently. Second, it naturally supports operations like undo, redo, logging, or patch execution. And third, it makes the system easily extensible. Adding new commands does not affect the invoker or existing clients. It's a very flexible and scalable design choice. Here you can see the UML diagram for the command pattern. Notice how the client sets everything up. It creates commands, assigns receivers, and passes commands to the invoker. The invoker simply calls execute on the command object. It does not know or care what the command is actually doing. This keeps the system beautifully decoupled. Let's look at a few real-world examples. A TV remote is a perfect illustration. Pressing a button sends a command to the TV without the remote needing to know how the TV processes that request. Similarly, in a text editor, pressing Ctrl Z triggers an undo command. Or think about a task scheduler that queues tasks and executes them later. Each task is simply a command. Imagine you are designing a smart home remote control. You have devices like lights, fans, and thermostats. Each action, turning a light on, setting the temperature, can be encapsulated in a command. The remote control just triggers the command without knowing what device it is actually controlling. This separation makes the system so much easier to modify and extend in the future. Now moving on to the mediator pattern. In complex systems, classes often end up directly depending on each other, creating a web of dependencies that's very hard to manage. The mediator pattern solves this by introducing a middleman, the mediator, which controls and coordinates communication. Instead of objects talking directly to each other, they send messages to the mediator. In the mediator pattern, we define a mediator interface which outlines how communication happens. The concrete mediator implements this interface and contains the logic for coordinating interactions. Each colleague object, like a user in a chat room or a plane in an ATC system, interacts only with the mediator, not with other colleagues directly. This separation makes the system much simpler and easier to maintain. The biggest advantage of the mediator pattern is reduced coupling. Instead of having every object talk to every other object, leading to tangled, hard to maintain code, you centralize all communication in one place. This improves scalability, eases debugging, and makes future changes much safer and faster. Here's the UML for the mediator pattern. Notice how all colleague objects interact only with the mediator and not with each other. The mediator acts as the single hub through which all communication flows. This architecture dramatically reduces complexity as the number of objects grows. We have already interacted with mediator patterns without realizing it. Think about a chat room. You send a message to the chat room server, not directly to another user. In air traffic control, planes don't talk to each other, they communicate via the ATC tower. Even in GUI frameworks, buttons, text, fields, and drop downs often communicate via centralized event handlers or mediators. Let's imagine a basic chat room. Each user called a participant registers with the chat room mediator. When one participant sends a message, they call the chat room's send method and the chat room forwards the message to the appropriate recipient. This design makes adding new users easy without needing to modify existing code. Now it's time for you to try. Design a smart home controller using the command pattern. Your system should include devices like lights, a thermostat, and a security system. You will need to define commands for actions like turn on, turn off, and set temperature. Focus on achieving complete decoupling between the remote control and the devices themselves. Similarly, practice designing an air traffic control system using the mediator pattern. Each plane will act as a colleague object and the ATC tower will be the mediator. Planes should not communicate with each other directly, only via the tower. The tower will coordinate when it's safe for each plane to land or take off, avoiding collisions. Your homework challenge is a little bigger today. Design a text editor that supports undo and redo using the command pattern. Each editing action, typing, deleting, formatting should be encapsulated as a command. If you want a bonus challenge, create a chat application where users communicate via a mediator. Both exercises will give you deep hands-on mastery of these two patterns. Let's summarize. Today we learned the command pattern helps us wrap a request into an object, giving us powerful control over execution, queuing, and undo. We also saw that the mediator pattern centralizes communication among objects, reducing messy dependencies and making systems easier to grow and maintain. Both patterns are vital tools in a designer's toolkit. In our next session, we will explore the observer pattern and the strategy pattern, two patterns that are crucial when building systems that interact with changes dynamically. Trust me, you will use them all the time once you master them. See you in the next class and thank you for your attention.